So in this clip, I want to show you how to process the results we got from the transient simulation we did in the previous video clip using this method, the lin-trans solver. So now to process the results we got from this method, we're going to use this method instead, TransPostProcessor, so trans for transient. And this is pretty straightforward, so we just invoke this method and then run the script. Okay, so now the processing is done, and if we go into our folder, we now have these new 10 files here. These are all these VTK files that we use ParaView to visualize and render. So now if we open ParaView, and open the files, so we now have them here, and this is a feature of ParaView. So it lumps together all VTK files that have the same name but different number indices into one, so you can open all of them as one chunk of files, basically. So we click OK and then load the files. So now we have the model here, and if we apply this filter, called clip, and we apply this normal like so, and then now we are at the initial value, time step 0. So if we look in our folder here, what we see now here in ParaView is this file with index 0. So if we want to look at, say, this file at time step 5, we simply type in number 5 here. Okay, so now the color scale changed a little bit, but now you see the principle here that the diffusion takes place from this surface. So this was the X back surface where the diffusion enters through, and then you see how it progresses slowly inwards. So this is a way of visualizing the result. So going back to the model, we had X back set, the coefficient here was 100 and the ambient humidity to 1. So what I want to do now is just to try to redo the same simulation, but we add a boundary condition on the back side. Or we could actually do it on, let's say here, we could do it on Y front side. So we add boundary condition to this surface as well to see what that solution will look like. So to do that, we will just close out here, and then we set Y front equal to 100, and then Y front equal to 1 here. And then we have to invoke this method again to redo the transient solver and then do the post-processing. So let's do that. So now the solution starts, and I will pause the video until it's finished. So now the computations are done, and we go into the folder, and we now have a new set of VTK files that we use for ParaView. So we open ParaView again. So, and then we apply the same cutting filter. And then we go to time step 5. Okay, now I just did a little bit of rotation here, but now you see that the diffusion has started from these two sides now, so the X back and the Y front surfaces, and you see how the diffusion slowly has started to penetrate this SVE. Okay, so this is how this transpost processor method works and how it's used.